Well, hi, this is my first shot at this TED Talk video thing, so having my morning coffee, and good morning. This is sponsored by Dunkin' Donuts Coffee, better living through Dunkin' Donuts, or how Dunkin' Donuts Coffee saved the world. Anyway, this is my elevator pitch, hopefully not to be in the best of crazy videos you guys get. My idea is to pull together some different technologies that have been out there. This is something that Connections did on PBS back in the early 80s. Great series. How one technology combined with the current technology combined with another one from different spots put together made the higher, greater good. The video you've probably seen out there, if you haven't, you really got to check it out. It's going to be on the list. Is the Death Star TV screen death ray. Okay, this is where they took the TV screens from the projection TVs that are now obsolete and turned them into a magnifying lens and melted a nickel, good, bad, or otherwise, roughly 1200 degrees. Watch the video. It's pretty impressive. So it was a parlor trick, but I think that it's got some merit in bringing energy and hopefully steam, electricity, and a lot of things to the third world. It's politically not correct anymore. To the poorer nations in disaster relief also. It's been a passion of mine. I could tell you stories, but this is the TV screen death ray. It's about how big it is. Pretty simple. I don't know if you can see me. Pretty flexible. Now it's just a piece of plastic, right? In manufacturing, a piece of plastic, 13 cents. The carbon footprint, I could talk about for hours, but the machines that are making these, or that used to make these, are probably heading for the scrapyard. So injection plastic molding, not a big thing, but some of these are better than others. You could ramp it up. I'd really like to make it so it rolled up, but that's what I'm going to talk about today. Okay, so believe me, the cloudy day that I have, slightly raining joke about solar energy, believe me, isn't lost. But I'm in a hurry, and I really need to get this out. My intentions are pretty altruistic. I can't do anything with this. I'm just a one guy in a garage. But I think it merits some further study. Okay, so in general, this screen, for argument's sake, is 1 square meter. I'm just doing that for the calculations that can be done at any time. But a square meter of photons shooting to one spot at 1200 degrees is a lot of energy in one little spot. Anybody could do it in their backyard, that kind of ramping down but ramping up at the same time. Okay, so in the video, if you haven't seen it, they take the screen on a stand and then on a platform and then focus the rays onto one spot and they melt a nickel. That's great. The current photovoltaic cells, you'd burn them. Nothing's going to survive that heat. I don't want to burn a solar cell. Okay, for the efficiency that I'm talking about, that'll ramp up the efficiency of solar energy, is to chop that angle back, say about there, which would make a round spot a cone, as you wish, and that surface area onto the photovoltaic you can maximize and off to electricity. Okay, so I passed by a really large solar array on 96, and they're doing it with all the very large solar cells, and I'm reversing that, and I'm taking all of the sun and putting it on a spot. That's going to come in important later, because if I can get all of the photons down to one spot, that minimizes the impact and makes it more portable to put on buildings, on cars, on top of houses, that kind of thing. Ramping up, imagine a whole bunch of these put down onto a single line in series. So you drop them down into a conduit and send that off to ramp up your electricity. That can be done by engineers. That's not why I'm here right now. That's the electrical side of the photovoltaic advantage of these TV screen death rays. Okay, so that's solar. Now we're going to go to steam, and this is where I think it's really going to come in handy, is on a smaller scale, bringing that down to a spot at 1200 degrees. I'm just throwing it out there, and the thought process is to shoot water through, turn it into steam, and then collect it on a cold sink for distilled water. Distillation. Nice and easy. You burn the water, collect it. It's filtered. It burns off bacteria, clean. That's distillation. Easy peasy. Now, my thought also is the combination of bringing in the graphene heat transfer element that was mentioned in the film. I've been a big fan of graphene. There's a place in Lansing called XG Sciences that I checked out, and I really tried to get in with them and really pursue graphene. But the new information that I got was in your film was the heat transfer. Hot, cold, hot. Nice, I like that. Maybe in a powdered form, in a tube, cranked together. Maybe I could do that, where the point comes in for heat, and then I can curve it to any direction that I want. I get the heat from the point, and I put the heat where I want it. Now, where I want it is, again, to boil water, make steam, things like that. While it's not a pedal bike for an hour a day, very cool. This is for sunshine, and obviously not on a day like today, but when it's really hot, you can crank up. I think if I can get a rotor spinning, or 2 rotors spinning, or 3 rotors spinning, and the steam turbine, just like adding pistons to an engine, I turn into this, let's just add them, plus another one, plus another one, plus another one, to where they're all working in tandem to boil the water and turn to steam. Steam turns a generator. Generator makes electricity. Then it goes on to another technology of battery. That's mostly what I've been pursuing as of late, and I apologize for this this first run really fast video, but this is an introduction of me and this idea. Hopefully, we can work together and put something out there to help people and save the planet. There's no carbon footprint other than the making of the materials in the machine. Sunshine is free. I could go on. We know those arguments, and my insights, I'm really enjoying. I had some ideas on the steam generator. Actually, a rotary system, really basic. It's only in the infancy, which is the first idea that needs to be compounded to better and better. Is where the flash boiling of the water in the steam engine actually turns the steam engine faster. It's not a perpetual motion machine. It's more of a recycling of the energy and efficiency to get this thing ramped up. I'll save that for another time. It's not a big thing. There's better people than I working on turbines, but I'd like to see this take off. Buzzword slam dunk, buzzword cheap, buzzword ramp upable. All of those great ideas I'd like to work on. I live in Fowlerville. I'm not far from Farmington Hills, and I would really enjoy joining the team, if not in the design, in as a lab assistant, a mechanic, a driver, a materials handler. I'll work. I'll sweep the floor. I really want to see this save the planet idea pushed forward, and if I can help it in any way, I would really enjoy it. Plus, I'm a rough carpenter. I work outside. I don't want to work outside this winter. I need a job. So, thank you for your time. I hope this gets to the right people, and please feel free to give me a call or email and see what you think. Thank you.